The history of the Big Bang Theory is a fascinating journey that weaves together centuries of scientific discovery, philosophical inquiry, and technological advancement. From ancient cosmological models to modern-day astrophysics, the development of the Big Bang Theory represents one of humanity's greatest intellectual achievements. This detailed exploration spans over 2,500 words and delves into the historical, theoretical, and observational milestones that have shaped our understanding of the universe's origins. Ancient and classical cosmology. The roots of cosmology trace back to ancient civilizations, where various cultures developed their own models of the universe. Early cosmologies were deeply intertwined with mythology and religion. For instance, the ancient Greeks proposed several models of the cosmos. Pythagoras, c. 570 to 495 BCE, suggested a spherical Earth, while Plato, c. 427 to 347 BCE, and his student Aristotle, 384 to 322 BCE, developed geocentric models, with the Earth at the center of the universe. Aristotle's cosmology, detailed in works like On the Heavens, posited a finite, eternal universe, with celestial spheres moving in perfect circles around the Earth. This geocentric model dominated Western thought for nearly 2 millennia. The heliocentric revolution. The geocentric model was challenged during the Renaissance by the heliocentric theory of Nicholas Copernicus, 1473 to 1543. In his seminal work, De Revolutione Orbium Coelestium, 1543, Copernicus proposed that the Sun, not the Earth, was at the center of the universe. This radical shift laid the groundwork for modern astronomy. Johannes Kepler, 1571 to 1630, and Galileo Galilei, 1564 to 1642, further refined the heliocentric model. Kepler's laws of planetary motion described elliptical orbits, while Galileo's telescopic observations provided empirical support, revealing celestial bodies like the moons of Jupiter that orbited objects other than Earth. Newtonian mechanics and the infinite universe. Isaac Newton, 1643 to 1727, revolutionized our understanding of the universe with his laws of motion and universal gravitation. In Philosophiae Naturalis Principia Mathematica, 1687, Newton described a universe governed by physical laws, where gravity acted as an attractive force between masses. Newton's work suggested an infinite static universe, as an infinite distribution of matter would create a balance preventing gravitational collapse. The nebular hypothesis and island universes. In the 18th and 19th centuries, astronomers began to speculate about the nature of nebulae and the structure of the universe. Immanuel Kant, 1724 to 1804, and Pierre-Simon Laplace, 1749 to 1827, proposed the nebular hypothesis, suggesting that solar systems formed from the gravitational collapse of rotating gas clouds. William Herschel, 1738 to 1822, and his son John Herschel, 1792 to 1871, conducted extensive surveys of the night sky, cataloging thousands of nebulae and star clusters. These observations hinted at the vast scale of the universe and the possibility of island universes, galaxies beyond the Milky Way. Einstein's relativity and the dynamic universe. The early 20th century brought a seismic shift in our understanding of the cosmos, with Albert Einstein's theory of general relativity. Published in 1915, general relativity described gravity not as a force, but as the curvature of spacetime caused by mass and energy. Einstein's equations suggested a dynamic universe that could expand or contract. Einstein initially introduced a cosmological constant, lambda, to allow for a static universe, reflecting the prevailing belief. However, this was soon challenged by observational evidence. The expanding universe and Hubble's law. In the 1920s, astronomer Edwin Hubble, 1889 to 1953, made groundbreaking discoveries using the 100-inch Hooker telescope at Mount Wilson Observatory. Hubble observed that spiral nebulae were actually distant galaxies, vastly expanding the known universe. More importantly, he discovered a relationship between the redshift of galaxies and their distance from Earth, now known as Hubble's law. Hubble's observations indicated that galaxies were receding from us, implying an expanding universe. This discovery provided strong evidence against a static universe and supported the idea of a dynamic cosmos. The Big Bang theory emerges. The concept of an expanding universe naturally led to questions about its origins. Belgian priest and physicist Georges Lemaitre, 1894 to 1966, proposed in 1927 that the universe began from a primeval atom, or cosmic egg, which expanded to its current state. Lemaitre's hypothesis, initially met with skepticism, laid the foundation for the Big Bang theory. In the 1940s, physicist George Gamow, 1904 to 1968, and his collaborators, Ralph Alpher and Robert Herman, further developed the Big Bang model. They predicted that the early universe was a hot, dense plasma that cooled as it expanded, leading to the formation of light elements through nucleosynthesis. Gamow's team also predicted the existence of residual radiation from the Big Bang, the cosmic microwave background, CMB. Discovery of the cosmic microwave background. The pivotal moment for the Big Bang theory came in 1965 when Arno Penzias and Robert Wilson accidentally discovered the CMB while working at Bell Labs. This faint uniform radiation provided the smoking gun evidence for the Big Bang, as it matched the predictions made by Gamow's team. The discovery of the CMB cemented the Big Bang as the leading cosmological model. Subsequent measurements, such as those from the COBE Cosmic Background Explorer satellite in 1989 and the WMAP Wilkinson Microwave Anisotropy Probe in 2001, further confirmed the Big Bang theory and refined our understanding of the early universe. Inflationary theory and the horizon problem. While the Big Bang theory explained many aspects of the universe's evolution, it faced several challenges. One significant issue was the horizon problem, the question of why the CMB is so uniform across the sky, despite regions being causally disconnected. In 1980, physicist Alan Guth proposed the inflationary theory, suggesting that a brief period of exponential expansion occurred just after the Big Bang. This inflationary epoch would have stretched out any initial irregularities, explaining the observed uniformity of the CMB and resolving other issues like the flatness problem and the magnetic monopole problem. Dark matter and dark energy. The 20th century also saw the emergence of two mysterious components of the universe, dark matter and dark energy. In the 1930s, Fritz Zwicky and later Vera Rubin observed that galaxies and galaxy clusters had much more mass than accounted for by visible matter. This unseen dark matter makes up about 27% of the universe's mass-energy content. In the late 1990s, observations of distant supernovae revealed that the universe's expansion is accelerating, driven by a mysterious dark energy comprising about 68% of the universe. The discovery of dark energy challenged previous models and led to the development of the lambda CDM model, which incorporates dark energy, lambda, and cold dark matter, CDM. Current understanding and ongoing research. Today, the Big Bang theory remains the cornerstone of cosmology, explaining the observable universe's large-scale structure and evolution. Key observations supporting the Big Bang include the CMB, the abundance of light elements, and the large-scale distribution of galaxies. However, significant questions remain. Researchers continue to investigate the nature of dark matter and dark energy, the details of cosmic inflation, and the potential for a multiverse. Advanced telescopes and observatories, such as the James Webb Space Telescope, aim to probe the universe's earliest moments and uncover new insights into its fundamental nature. Conclusion: the history of the Big Bang Theory is a testament to human curiosity and ingenuity. From ancient speculations to modern astrophysics, the journey has involved a continual refinement of our understanding through observation, experimentation, and theoretical innovation. As our knowledge expands, the Big Bang Theory continues to evolve, offering profound insights into the origins and fate of the universe. Thank you for watching. Please subscribe our channel.